Thank you all for taking out time and joining me in today's session. I hope you're able to hear me clearly. Today is day 2 of our Azure security series. We covered day 1 last Thursday, where we spoke about identity, we spoke about multi-factor authentication, and other topics related to identity. Today, we look at the topics such as, let me just switch to the next slide. We look at topics such as perimeter security, network security, and host security. So these are the 3 topics that we'll be covering today. As always, if you have any questions, please use the chat or the question and answers uh, panel, and we'll be more than happy to go ahead and take up your questions during the demo or frequently throughout the session and answer it. Before I go ahead and continue with the session, I would appreciate if everybody can participate in the poll and let me know if you're able to hear me clearly. I'd request everybody to participate in the poll and let me know if you're able to hear me clearly. In case you're not able to hear me clearly, please do let me know in the chat or the Q&A. I see that everybody is able to hear me clearly. That's good to know. I also want to quickly understand the role that you're currently in so that I understand the audience or the persona in today's session. I'd appreciate, again, if you can participate in the polls and give your feedback. Okay, wonderful. So I see there is a good mix of management, technical architects, and support engineers. There are a few business development managers as well as part of the session. So this session or every session part of Azure Security Series is, I would say, slightly more technical than marketing or sales oriented. But if you are curious to learn more about Azure Security and its features and functionality, you're definitely in the right session. Thank you very much for participating in the poll. And a quick introduction about myself. My name is Roshan. I've been working with Ingram Micro for the last 4 years now. Spent 2 years in Ingram Middle East and 2 years in Australia. I've been a Microsoft guy pretty much throughout my career. I started with SharePoint, then moved to BPOS, Office 365, and started working on Azure when it was known as Windows Azure. I'm primarily focusing on infrastructure as a service side of Azure. So security, automation, making sure you have the right infrastructure in place to cater to your applications that can be virtual machines, containers. I've also dwelt lately into serverless technologies as well, which is function as a service. So that's what I do. I help partners design and develop solutions around Microsoft Cloud. I also work with related technologies on Microsoft Cloud, such as backup and disaster recovery solutions from Veeam, Veritas, Commvault, DoubleTake, things like this. I'm based in Melbourne, and if you'd like to get in touch with me, my email address is displayed on the screen. So feel free to drop me an email if you have any opportunities, any questions on Azure. Drop me an email. I'll be more than happy to look at it and revert as soon as possible. So today's session definitely has a lot of content, so I'll try to keep it crisp and to the point. If you have any questions or if you want me to go into details of a particular slide or a particular technology, do let me know so that I can dive deeper into that particular topic. So we'll start off with perimeter network. Perimeter network is the most fundamental security that every organization puts in. It typically starts with a firewall in place, which separates your corporate network with the outside world. So in Azure, it is no different. Azure has various layers of security. The physical security is taken care by Microsoft, making sure that nobody gets unauthorized physical access into the data centers or physical access to the network or the rack servers, which are placed within Microsoft Office or Microsoft data center locations. That's something Microsoft takes care. If you'd like to know more about the security in place, you can visit the site trustcenter.com. .microsoft.com. They have very detailed information in terms of how the data centers are performing, what kind of security is in place. They have biometric scanners, iris scanners, CCTVs, dual factor authentications. So there are several security checks that a person has to go through, even in order to qualify to go ahead and access physically the data centers. Now, apart from that, the next level of security is identity. Now, this is something that we covered in great detail in the first session, right? So identity and access management, things such as how you can make sure your Active Directory is synced with Azure AD, what is Azure AD domain services, how you can join your machines to domain services and make sure they are compliant. We looked at privileged identity access, we looked at multi-factor, we looked at conditional access. There are several features and functionality now available around identity, and in today's modern world, perimeter security is no more the boundary for your security implementation, right? So identity has now become the new, uh, I would say, security parameter around which you need to have your security strategies defined, because identity can now be people can log in from office, from home, from an office given laptop, from their own mobile devices. So identity is the constant thing that travels from different locations, from different devices, and having a security around identity is definitely very important, and that we covered in greater detail in the first session. In today's session, we'll go into deeper layers. We'll start off with perimeter. There are several topics such as firewall and DDoS that we'll look at. Then we'll look at network and compute. In the next session, which is the day 3, we will be looking at application and data, where we'll talk more in terms of, let's say, SQL security and application security in the next session. So today we are covering 3 topics: perimeter, network, and compute. So to get started with respect to perimeter, I'm sure everybody is aware of DDoS, right? DDoS has been one of the most used, I would say, technology or most used attack method by several attackers. It is one of the ways where they send all or a lot of traffic to a particular network or to a particular IP, making sure your systems uh, are not able to perform their day-to-day activities. A very common attack, even in Azure, I've come across customers who have, let's say, IoT application running on-prem. They have websites running on Azure where they have not taken enough security measures to protect it or even to monitor it, and they have seen a huge spike, one, in their consumption bill, and second, the service becoming non-responsive, right? So it's very important to have measures around uh, DDoS attacks, and Microsoft does have certain capabilities enabled by default, but they still give you all the features and functionality which you can use in order to further drill down into how you can go ahead and enable DDoS, monitor it, and make sure you have policies around it. So within Azure, specifically for DDoS, there are 2 plans. There is a basic and a standard plan. Now, the basic plan of DDoS protection is enabled for every customer using Azure, right? So this basically makes sure your traffic is monitored. It takes care of mitigating known attacks, and making sure not Azure services, no Azure services are impacted because of any DDoS attack, right? But what it doesn't take care of is the specific public IPs which you would use, which can be part of your firewall, load balancer, or even virtual machine protection around those public IPs which get created. just specific for your implementation. Now, this is where the standard plan of DDoS comes into place. Now, this is again a service that works on these IPs, so there's no application change that you have to do. It is basically monitoring the traffic coming in and going out on the public IP. So for example, as you can see in this graph, if you have anomalies, if you have unexpected spikes in terms of traffic coming through or going out of that IPs, then the standard plan has the intelligence to alert you, to give you the details of from where and how this traffic is being originated. So in a demo, we'll quickly look at how you can enable standard plan and how you can associate it with the public IP. So we do have quick demos as part of the session, and I'll quickly run through the DDoS piece as well. The next piece is firewall. Now, on Azure, you can definitely host your own firewall. For example, if you're using Sophos or SonicWall or Cisco firewalls, any third-party firewalls, most of the firewall companies have their own virtual appliance, right? So you can always bring in your own firewall using bring your own license model, deploy your firewall as a virtual appliance, and protect your Azure network, right? If you are looking for a native Azure service, then Azure Firewall is an answer. Think of Azure Firewall as a stateful firewall as a service. So there is nothing that you have to manage in terms of making sure the firewall is up and running, making sure the high availability or the load balancing of the firewall is taken care. So all of those pieces are taken care by Microsoft. Um, all you need to worry is things like, let's say, creating the NAT rules, creating the allow deny rules through firewall that you typically do as a firewall engineer, right? So Azure Firewall is a completely managed cloud-based service. It definitely integrates with most of the Azure security and monitoring services. For example, it integrates with Azure Monitor, it integrates with Azure Security Center. You can even send Azure Firewall logs into Azure Sentinel for log analytics or analyzing the traffic as well. So all those integration is definitely very much possible. You can integrate Azure Firewall with your on-premise firewall in terms of making sure all the connections from your office, on-prem office is going through the Azure Firewall and then into the Azure network, or any traffic coming out of the Azure network goes through an Azure Firewall and then over to the internet. So all those various features and functionalities which are found in a firewall is all available within Azure Firewall as well. The next topic is VPN Force Tunneling. Now, the VPN Force Tunneling is a feature where you can make sure that the traffic is being routed through a route which is controlled and managed by you, right? So, for example, as you can see in the image, you do not want traffic from the application tier or the database tier or mid tier in the backend to directly go to the internet. You want it to go through your, let's say, on-premise firewall or the on-premise network and then over to the internet, but the front end, the web front ends can interact with the internet. So this is the VPN Force Tunneling option, which is available in Azure, where you can redirect internet-bound traffic through the company's backbone infrastructure. Now, this can be for auditing purpose, inspection purpose, making sure you're receiving traffic from legitimate locations, and then passing it on to internet. For example, if you have a support team or an application team which is doing I'm sorry, it seems that people are not able to hear me. Let me just double check. Oh, okay. There was a message from some people saying they're unable to hear me. Okay. Thank you for people letting me know. I see that everybody is able to hear me. Some of them may not be. I think the issue might be at your end now. Let me go ahead and reshare the screen. Sorry, let me go to the slide just a second. Force tunneling. Okay. Let me make sure I'm sharing the screen. Yeah. So sorry for that, ladies and gentlemen. So coming back to the topic, force tunneling, right? So you can always make sure that traffic is routed through the VPN, the site-to-site VPN that you set up. One of the classic examples that I've seen some of the companies implementing is, let's say if you're running Azure on to host your infrastructure, and you're running a couple of applications, and you have a service vendor who's managing one of those applications. Now, you do not want the service vendor directly to access your applications over the internet, right? So you want him to go through a safe route via site-to-site VPN that you have given. Let's say you've given him a VPN client via which he can access the backend or the mid-tier for maintenance, for update patching, or even for break fix issues. That's one of the ways of how you can make sure the right request is traversing through the preferred route and having access to your applications. The next one is user-defined routes. Now, similar to VPN Force Tunneling, user-defined routes are used to override the default way of how traffic moves, let's say within Azure, or even a request coming from outside from the internet into Azure. For example, let's say you have a three-tier application. You have a front end, you have an application, and you have a database tier, right? This In this scenario, if you want to make sure that the data from your web front end, before it reaches the mid tier or the application tier, you want it to go through uh, an analytics tool or a security tool just to analyze the traffic coming from your web front end to your application. You can use user-defined routes. You can say that any data coming into my application server should only come from a specific IP, from a specific range of IP, and you can redirect the traffic. So that is possible within user-defined routes. Okay, I see people saying the audio is not very clear. Let me quickly switch to a better audio. Okay, I hope now it's clearer. I would appreciate if you can participate in the participate in the chat, and just let me know if my voice is better than last time, better than previous, I would say. So, okay, so I see that it's been clear. The static. Okay, so now it seems that everybody is able to hear me clear. Okay, wonderful. Sorry for that. I think the headphones which I was using had some static in it. But anyways, coming back to the session, user-defined routes. So like I said, you can define how the traffic has to flow between virtual machines, between networks, right? So you can have n number of user-defined routes created and define how the traffic should flow. Particularly useful when you have multiple applications, or if you have multiple layers of application and you want to analyze the data coming through these different layers. You can analyze the data coming through from load balancer to front end, from front end to mid tier, from mid tier to database tier, right? Again, we'll quickly have a demo around
user-defined routes, and we'll see how well or how efficient we can go ahead and make changes to it. Okay, so let's jump on to a quick demo. Again, let me go ahead and share my screen. And okay, so let me just reconfirm. Okay, so I'm sharing my screen where I've opened up an Azure Management Studio. So to start off with, let me quickly talk about DDoS protection. So if you again search for DDoS protection plans, this is the page that you'll come into. Like I said, the basic plan is already enabled for every customer who's using Azure. The standard plan is where you will have to go ahead and create and assign it to a resource group and an IP and an IP, right? So I've already created the standard protection plan. And if you look at protected resources, you will see that it's a particular VNet that I've selected. And this VNet is being now protected. Now, if you'd like to go ahead and configure alerts notification, I can go ahead and create an alert saying, so if I edit this resource, I'm basically selecting the same resource here saying this is my protection plan. And under conditions, I can go ahead and search for, let's say, all administrative DDoS protection joining, or I can select all services, all types of attacks, and look at how I can go ahead and create options where I can go ahead and create rules for attacks, for notification, for monitoring. All those alert options can be created right from here. Right now, in terms of metrics, again, I can see how my DDoS protection has been happening. Now, this is a internal IP which I've assigned, so there's not a lot of metrics to be shown, but this is where you can go ahead and see whether there has been a surcharge of requests coming through that particular IP or not. And you can also drill down to see what's the originating location, what's the originating IP from where these DDoS attacks are happening from, right? So these are the detailed information that you would find within the DDoS protection. Now, similarly for DDoS, if you search for Azure Firewall, you can go ahead and create your own Azure Firewall. Now, again, the creation takes a little bit of time, so I've gone ahead and pre-created it. And within this, it is similar to how you manage your on-prem firewall, right? So if I go to rules, I can create NAT rules, I can create application security rules, I can go ahead and configure the public IPs which I want to create. It comes with its own DNS. If you'd like to manage your DNS as well using Azure DNS, you can go ahead and manage that as well. So to show you a quick demo, what I'll do is let me go back to, let's say, the rules. I'll go ahead and disable this particular rule for now so that I can show you some of the examples. So I'll go ahead and delete this. Okay, it'll just take a minute for it to be updated. But if I open up the resource group saying firewall demo, what I've done is I've created a virtual machine. Now, this particular virtual machine doesn't have a public IP, right? It only has a private IP. Now, I want to create a NAT rule so that from my public IP, I'm able to access this particular virtual machine and make changes into it, right? So option one is to use Bastion, which is something that we'll be covering when it comes to host security. The second option is to use firewall, right? So in the firewall, I can create a simple NATing rule saying NAT the public IP of my Azure firewall and redirect all the traffic coming on port, let's say 3389 to this particular IP address, right? So that's the simple firewall rule, which NAT rule that I can go ahead and create. So if I say add a NAT rule here, okay, the firewall is still being updated. So once it is updated, I can go ahead and quickly create a NAT rule that allows me to update or allows me to go ahead and access the virtual machine, right? Now for that, I would need the public IP of my firewall. So let me open another tab and copy the public IP of the firewall. So this is the IP, my firewall. So I'll create a rule saying allow RDP, for example. The priority I'll give 1000. Again, RDP access protocol. I can say TCP source. Now, source, what I'll do is I'll go ahead and put in my public IP. So my public IP address is this one here. Destination, paste the address. Sorry, destination is this. This is port 3389 translated into the virtual machine IP address. So like how you create it in an on-prem, simple, easy, quick to go ahead and do this. So if I go ahead, copy the IP address here, translated 3389. Right. So before I go ahead and save this, space here, yeah. Here I think there's space, yeah. And before I go ahead and click add, let us first test if I am able to access the virtual machine. So if I download RDP, as you can see, private IP, there is no public IP associated with it. And of course, I'll not be able to access this, right? So I'm trying to access I don't have any site-to-site VPN connection, so this will definitely fail. But if I go back and say add, so once the NAT rule has been updated, then I should be able to go ahead and access this particular virtual machine from my laptop, which is mapped to my public IP address, right? So that's a simple example of how you could use firewall. The second option, while that rule is getting created, is you can also create application rule connection. Now I've created a rule saying allow website. So from that virtual machine, if I want to restrict certain IP, certain connections, certain protocols, I can always go ahead and configure rules on the application rule connection. For example, here, if I remove this rule and make sure that all the traffic is going through my firewall, right? And in my firewall, I've not given it permission to open any websites, then the virtual machine will not be able to open any website. So here I can create this application rule connection where I can go ahead and mention what are the things that I allow it to connect. It can be SQL Server, it can be websites, it can be HTTPS connections that can be uh, to your applications which are published. So all those things can be configured within Azure Firewall. Now, how do you make sure that all the connections from the virtual machine is always routed through the firewall, right? So how do you make that connection? That is where user-defined routes come into place, right? So again, user-defined routes, there's no cost with it. So if I search for routes, there's something called as route table. And again, I can go ahead and create a route table where it says, so I've already created one. So the route says any outgoing address, the next hop is my internal IP of my firewall, right? And it is associated with my virtual network in which my virtual machine is run. So this is how you create UDR or user-defined routes. You create a route saying, if I click on add here, you just give it a name, address. So this is their destination address. So if I put 0.0.0.0, it's basically saying uh, any internet IP address, and I can say what is my next hop. I can say virtual network gateway, virtual network, internet appliance. So in my scenario, I'll be using virtual appliance and the internal IP address of my firewall. Right now, once this is created, I can go back and create subnet. So now I have created the route, but to which network is this route associated to? Right? It will be the VNet or the subnet where the virtual machine is located. Right? So this is how you can create user-defined routes with firewall and protect your internal virtual machines from communicating to external world. A lot of customers already use UDR, especially when they have either their own virtual appliance used as a firewall or using Azure Firewall, or a lot of customers actually use application gateway as well. Again, what is application gateway? We'll come to that in our network security. So a lot of customers try to send the traffic through application gateway or through the site-to-site VPN through their on-premise firewall and then over to the internet. So for all those configurations, user-defined routes is what you could effectively use. So again, if you have any questions, please feel free to use the chat and let me know. OS, if you can elaborate on your question, that'll be helpful. Don't we have to enable the security rule? I'm not sure if it's a comment or a question. So if you can elaborate, that'd be helpful. So Patrick, if you missed the first session, not a problem. I'll be sending out the recording of all the sessions tomorrow, which is the first session and the second session. I'll be sending out those details by tomorrow. Can we back up rules and restore them? If you're talking about user-defined routes, there is no option to back it up, but you can always export the user-defined routes. So that is one option for you available, where you can go ahead and export or create a template of your user-defined route and have it exported. And let's say tomorrow you want to move from subscription to subscription, you can definitely go ahead and redeploy. That's one of the options. There is no backup and restore there. It's more of an export and import kind of a scenario. Okay, so going back to the slides. So OS, to answer your question, after the NAT statement, do we have to enable security rule? Yeah, the security rule is what is user-defined route, right? Now, if you don't enable the security rule, your virtual machine is pretty much open to the internet. So the user-defined route tells the virtual machine that all traffic should go through the firewall, and within the firewall, it's up to the business requirement what application security rules you would like to create. It's not a mandatory or a prerequisite for you to use application security rules. It's more depending on the business requirement that you use. But with firewall, make sure you have user-defined routes so that you're effectively moving the traffic through the firewall, and all the traffic to the virtual machine is also coming from the firewall. Okay. So I hope that answers all the questions. Keep your questions coming within the chat and Q&A. I typically will review them during the demo or post-demo and hopefully answer them. So the next one is network security. So we looked at perimeter security. We looked at DDoS protection. We looked at firewall. The other concepts, which is VPN tunneling. Once you have a site-to-site VPN setup, you can definitely try that as well. Again, with force tunneling, you still would end up using route tables, where you say that any data going out of my mid-tier or backend should be routed through my virtual network gateway, right? So one of the option you saw in the drop down was virtual network gateway. So that's how we would do a force tunneling using UDR and VPN force tunneling option. Under network security, the first option that we'll be talking about is network security group. Network security group is the fundamental security that is applied around Azure Virtual Network and Azure subnets. Again, think of it as a subset of your firewall, right? A smaller version of your firewall where you can say uh, from which port, which kind of traffic is allowed or denied, right? That is what network security groups also do, right? So it's associated either with a virtual network, a subnet, or even a NIC card, for example. And it basically says what's allowed, what's not allowed. So a simple example is this, right? So let's say if you have 3 virtual machines and you want to allow HTTPS and SQL communication, this is how you can go ahead and create. And on the right hand side, you see a table of network security groups. So it has to be associated with each machine, and you can go ahead and create these detailed rules uh, within that network security groups. Again, there's no cost associated with network security groups. You can create any number of network security groups. Now, one of the pain points of network security groups is that you have to go ahead and create it for each and every machine. There is no logical grouping of machines. For example, let's say you have a couple of machines acting as web front end, couple of machines acting as application or mid tier, and another machine acting as a database. You would like to create certain rules common for web front end, certain rules common for the database, right? So when it comes to logical grouping, that is what is missing in network security groups, and that is overcome by using application security groups. So application security groups is more of an extension of a network security groups where you're able to logically group items and then configure rules on top of it. So if I take the same example, so let's say you have 3 machines in blue acting as web and 3 machines in green acting as SQL, you can just create 2 rules, right? Which is for all web, allow HTTPS, and for all SQL, allow 1433, which is the default port of your SQL. So this is how you can combine network security groups and application security groups and allow and deny access to it. Again, in a quick demo, I'll quickly show you where you can find network security group and application security group and how you can create those rules. One of the very interesting services available within Azure is allowing you to integrate infrastructure as a service with platform as a service. For example, let's say if you have a virtual machine which is running an application, and that application wants to read and write data from Azure Blob Storage. Now, Azure Blob Storage is a platform as a service. Azure Virtual Machine is an infrastructure as a service. So how can you integrate these two? So that is where we will talk about service endpoints and private endpoints. So these are two technologies which allow and actually give you more control than just allow, which give you control in terms of how you want your traffic to be routed from uh, a virtual machine into, let's say, an app service or a storage, right? So we'll consider storage as an example that makes it easier for you to understand. So in this diagram, as you can see, I can go ahead and configure my internal virtual machine to talk to SQL database as a service or storage, or somebody using another virtual machine in a completely different network. I can make him go through the internet and come into Azure network again and talk to the storage. So these are various scenarios that we see day to day. But how can we control? How do I make sure that, for example, all the traffic that my applications interact with do not go on the internet and come back into Azure. I want all the traffic to use, let's say, the Azure backbone itself. So that is where Azure service endpoints come into place. So there are two broadly options. One is service endpoints, and another one is known as private link, which I'll talk in the next slide. So service endpoint basically allows you to access Azure platform as a service over a public IP. So in this scenario, the public IP is associated with the platform as a service. Every Azure platform as a service, especially things like storage and database, all of them have public IP addresses. So your internal virtual machine private IP is able to communicate to the public IP of the platform as a service using the Azure backbone network. So your network is, so your traffic is not going out into the internet and then coming back into Azure, right? So this is something that we can configure using Azure service endpoints. And typically service endpoints are configured at a virtual network level, right? So you're basically allowing the virtual network of your virtual machine. So if I pick up a highlighter here, you're basically allowing the virtual network of this virtual machine to communicate to the public IP associated with this, let's say, storage account, right? Now, the same scenario, if you set up a site-to-site VPN, you can also configure your on-premise network to talk to the public IP of your storage account, right? So that is what is service endpoint. So in this scenario, all the traffic from Azure, from this virtual network is not going through the internet and then coming into the coming into Azure again. It is directly communicating from the virtual machine into storage using the Azure backbone network, right? So the next option is called private link. So private link is, let's say, a step ahead of service endpoints, right? So private links makes you communicate between the Azure IaaS, which is infrastructure as service, to another, either a platform as a service or to another network through the private IP addresses itself. So if you compare it with service endpoints, there is no public IP involved when it comes to Azure private link. So the platform as a service and the infrastructure as a service are all communicating through internal private IPs. So in this scenario, it's more secure, more refined, and you can make sure there is no public access happening to any of your applications or data, right? So a quick comparison, if you see here, for service endpoints, it basically goes through like a firewall or through a public IP and then talks to the service endpoint. But on private link, it is directly, let's say, from a NIC card to a NIC card kind of communication, right? Again, I'll quickly show you a demo of how you can configure service endpoints when we reach the demonstration stage. The next one is application gateway. Now, Azure has various options to control the web traffic. One of the option is Azure Application Gateway. Now, this Azure Application Gateway acts as an intelligent, I would say, load balancer, right? So it's an intelligent load balancer where it is able to understand the incoming request, do URL-based rerouting, and is able to do things like SSL offloading as well, right? So this becomes your HTTP or HTTPS listener, and then based on the HTTPS traffic or HTTP traffic, it is able to route that traffic to different services within Azure. For example, let's say you have a web server, a file server, and a database server. Now, all the normal requests of accessing web should be redirected to the web server, But if you have incoming request access, which request for a file or which request for an image, that has to be rerouted to the file server instead of the traffic going to the web server. Right? So those are things that you can go ahead and configure within the application gateway feature of Azure. Now, the application gateway also has another feature called as Web Access Firewall. So, Web Access Firewall is think of it as a regional firewall, which you can go ahead and configure uh, similar rules to allow and deny traffic, right? So that's another functionality available within the Azure Application Gateway. The other two global services that are available are Azure Front Door and Azure Network Traffic. I'm sorry, Azure Traffic Manager. Now, both of these are global service, which means they work at a layer where any incoming request into Azure can go through Traffic Manager or Front Door. Now, Traffic Manager, think of it as a global DNS. So it basically sends traffic to location 1 or location 2, right? So it's like a global DNS. It doesn't really care or it doesn't really look into the traffic coming from the client to the service. It is simply redirecting traffic. Front door is an intelligent, you can say intelligent load balancer, right? So it understands the traffic. It understands HTTP, HTTPS, API connections, cloud services, and it is able to go ahead and route the traffic to the right location or to the right service, depending on the request. So the protocols that front door understand is primarily web traffic, which is HTTP, and it is able to go ahead and route based on the various HTTP requests. So depending on, for example, URL, it can redirect traffic to a certain server or a certain storage location, and depending on traffic, it can route it to, let's say, let's say containers or virtual machines. So it's an intelligent HTTP load balancer is what I would say. So moving on to the next slide. Again, if you have any questions, please do let me know in the chat. So this is a quick flow chart that I've put into place that will help you identify which is your preferred option to choose, right? So for example, if you are setting up a web application that uses HTTP or HTTPS, and if it's an internet-based application, and if it is not globally deployed, right? If it is not something that people from various location access it, then you can straight away use application gateway. So if you have a web application internet facing, which is only accessed by people in, let's say, Australia, right? So that's a classic example where you would just use application gateway. But if it is a globally deployed where you have people from, let's say, US accessing it, so you have an instance of that application running in US, you have an instance of it running in Australia, and then you see whether you require SSL offloading. If no, then is it hosting on any of platform as a service or infrastructure as a service? Though then you can either combine front door or just use front door with application gateway. So this flowchart helps you understand which component is suitable for your scenario, especially when you're accessing applications which are regionally located or which are located in multiple regions. Okay, let's jump on to a quick demo and look at network security group, application security group, and service endpoints. Let me go ahead, share my screen again. Okay. So like I said, network security groups, application security groups, these are associated with virtual networks. So let me go ahead and open one of the virtual machines and open one virtual network there. So if I go to the networking settings, right? So this is where you can see inbound, outbound, and application security groups, right? So this is where you can go ahead and create your network security groups. So network security groups, like I said, if you go ahead and click on create, you can say, what is the source? Is it coming from an IP address? It is coming from a service tag, or is it an application security group? Source port, destination. What is the destination? Is it a service? Is it a specific protocol that you're using? Define the port range, define the protocol, allow, deny, right? So very similar to a firewall a rule, but this is being now scoped to a specific network. Now, application security group, like I said, you can go ahead and configure application security groups for allowing it to go ahead and configure for the entire subset of a virtual machine. So the first thing you have to do is go ahead and create an application security group and then associate that application security group with this particular network, right? Now, network security group is stateful, which means if you create an inbound port, it also creates an outbound port rule, right? And same holds true for network security groups as well. Okay. The next one, which I want to quickly cover, is service endpoints. So for service endpoints, if I go ahead and open up a storage account, let's search for storage account here. Okay, so let's say this is one of the storage accounts that I have. Now here, if I want to go ahead and look at networking, by default, you will have allow access from all networks. So this is the default configuration, but here is when you can go ahead and select, no, I do not want data from coming into the storage from all locations. I want it to come from specific locations, right? So that is where you can say create selected network or choose selected network, and here you can go ahead and add your existing virtual network. So what happens is this this storage account can only be accessed from a particular virtual network, or let's say resources associated with that virtual network. Now you can also go ahead and configure the firewall and make sure you allow only, so for example, my public IP is shown here. So I can say that data coming outside Azure should follow this rule. So it should only allow traffic to come from a certain IP or a certain IP range, right? So both of these configurations will actually let you configure service endpoints. So this is what is service endpoints, making sure you're connecting infrastructure as a service and platform as a service and routing the traffic through the Azure backbone network, right? So that is where you can go ahead and create a service endpoints. For private endpoints, you actually need to go ahead and create a private endpoint, associate that with your platform as a service. So basically what a private endpoint does is it goes ahead and creates an internal DNS name and an internal IP address. Associate that with, let's say, my storage account, and using the internal DNS and the internal IP, I will be able to communicate from my virtual machine to this particular storage account. Right, so that is how you can go ahead and configure private endpoint connections. Okay. So I hope you now have a much more clearer idea of what is service endpoints and what is private links. If you have any further questions, please use the chat or the Q&A to let me know. So the last topic which we'll be covering is host security. So host security is basically talking about virtual machine security, right? Virtual machine is probably the most used service within Azure. So the first option is to make sure you have a tighter security around remote access management. So most of the virtual machines today, when get created, come with a public IP, which is not typically the best practice. You should not have IP, especially for your mid-tier and your database tier, create virtual machines with public IP. Always have them created with private IP, and either use Azure Firewall with a NAT rule or use a virtual appliance with a NAT rule to access it, or you could use something called as Bastion. Think of Bastion as a jump box as a service. So what is jump box? Jump box is a machine which is between internet and your internal IP address, and you can only access the internal um, resources via the jump box, right? Now, what Microsoft has done is they have made it as a service instead of you creating another virtual machine and creating rules so that people will access first this virtual machine, and from that virtual machine they access the internal resources. They have created a service out of it. So Azure Bastion will give you access to the virtual machines from the internet over a secure channel, right? You can either RDP or you can do SSH for your internal applications. Again, Azure Bastion is a paid service. It's not a free service. So a lot of customers typically end up using Bastion because it scales across a virtual network, right? So all the virtual machines, whether it is subnets, multiple subnets created within that virtual machine, can end up using Bastion. And then that's one of the reasons why it's cost effective and also a very secure way of making sure no unauthorized access happens to your virtual machines. One of the other use cases that I've seen is privileged access workstation. So let's say one of the privileged access workstation can also be SQL Server, right? Or your domain controller, right? So these are privileged access workstation which have very sensitive information, and only certain people should have access to this particular workstation or to this particular virtual machine. So this is where you can use things like uh, Bastion service and give dedicated accounts so that only certain people can use Bastion in order to log in to this privileged access workstations and do their day-to-day activities. The other very important host security is update management. I'm sure all of you have now come across the Exchange update that Microsoft released, which will go ahead and patch your on-premise Exchange servers. That shows how critical and important update management is, whether it is application update or even your operating system update. Microsoft has gone ahead and created an automated service using which the service can keep checking whether there is a new update released for whether it is Linux or Windows. It keeps checking if there is a new update released specific to the operating system that you're running. And you can go ahead and configure, or you can go ahead and schedule how you would want the updates to be applied to your virtual machine, right? So again, think of it as a Windows update server as a service made available within Azure. This is something, again, a lot of my customers use. It helps you track which machines are compliant, not compliant, and also help you schedule how you can update the machines. So I have a quick snapshot from one of the tenants. So as you can see, the update, the automation service keeps checking which virtual machines are updated. It even goes to a level that says which virtual machines are not applied with critical updates and which virtual machines are not applied with optional or security updates, right? So it gives you that clear differentiation in terms of what kind of updates are not applied, which virtual machines are up to date, and things like this. Another very important aspect on security is disk encryption. Now, typically all data that is stored within Azure is encrypted at rest, right? So whether it is disk or blob, all the data is encrypted at rest. But let's say if it's a disk and somebody with unauthorized access downloads that particular VHD or VHDX file from Azure into an on-prem, then that data is no more secure, right? So how do you make sure that your data is secure no matter where the data resides? So whether it is on Azure, or if somebody downloads that or restores that virtual machine to an on-prem, then it is still encrypted. That is where you use disk encryption, making sure that it is not only secure in Azure, it is secure wherever it is being transferred to or restored to. Last but not the least is endpoint protection. So though you have remote access, though you have update management, end of the day, it is still very important to have an endpoint protection on all your virtual machines. So that is where we recommend Microsoft Defender for endpoints. It's a completely 100% cloud-based EDR solution. It collects data as part of the sensor. So there is typically no installation that you have to do. It is already part of Windows 10. The agent is already available. It is not active. All you need to do is make it active, and each customer data is sent to a dedicated tenant. So it is not the data doesn't just go into global Azure. Each endpoint, each Microsoft Defender for endpoint gets his or her own tenant, similar to Office 365 Azure, and only data is stored within that tenant for, let's say, further analysis, further remediation steps. Um, you get a complete endpoint solution with Microsoft Defender. So a quick snapshot of it, it gives you threat and vulnerability management. It gives you protection and security around attack surface reduction. It gives you EDR, endpoint security protection. It also allows you to do auto investigation. So you can actually create rules where if you see certain kind of vulnerability, certain kind of attack, you can define what are the remediation steps to take care and solve it. And now Microsoft has also introduced Microsoft Threat Expert. So if you are a customer who is seeing a particular activity or a particular event happening within your organization which you have not come across, you can always get in touch with the Microsoft Threat Experts, and these people can analyze logs and help you in real time, right? So Microsoft has taken up that level of integration where it is not just automated, you even have a physical Microsoft engineers helping you to remediate the issues. So let's quickly look at remote access management and update management. Okay, so like I said, in order for you to go ahead and enable remote access management, what you have to do is enable a service called Bastion. So this is a service that you have to go ahead and create. And once you create it, you actually go ahead and associate it with a particular network, right? So here is where you select, let's say if I select a particular resource group, then I can go ahead and select that particular network within that. So these are the various networks that I can go ahead and select. So what this does is it creates a public IP address associated with Bastion network. So you can use this public IP in order to log into Bastion service, and then Bastion service will let you log in to your virtual machines using the private IP address, right? So you're not directly logging in into your virtual machines using a public IP. So this is what Azure Bastion service does, a jump box as a service. Another demo is automation. So I've created an automation account, and in this automation account, if I go to update management, let me see if I have any virtual machines associated with this. Okay, so I have few virtual machines associated, and as you can see, most of them are compliant. Some of them are still missing some updates. There are virtual machines that I have which are missing updates. So these are some of the updates that are missing, which I can go ahead and update my virtual machines, and I can even create a schedule, right? So I can create a schedule, which updates to include, which updates not to include, pre and post scripts. So all these options are available within the Azure automation account, and you can go ahead and configure it for your virtual machine. So again, I would strongly encourage you, if you have not configured automation service, do go ahead and configure it. It keeps checking based on your virtual machine operating system. Like I said, if it's Windows 10, Windows Server 2012 R2 or 2016-19, definitely keeps checking for the relevant updates and lets you know how you can schedule it as well. So yeah, I think that pretty much summarizes the session for today. So a quick summary: we looked at perimeter network. So we looked at DDoS protection, Azure Firewall, VPN tunneling. We looked at network security, ASG, NSG, for Azure front door, service endpoints, private links, and we looked at the last one, which is host security. So if you have any questions, now is the time when you can go ahead and ask your questions. Before I end today's session, the quiz for today's session is up. So let me go ahead and bring up the quiz. So this is the questions which will help you win the Star Wars saber that we're giving away. So the first question is up on the screen. So I'll read out. You deploy an Azure virtual machine that is configured to analyze network traffic. You need to ensure that all the network traffic is routed through virtual machine one. What should you use? Should you use an application security group, a network security group, or a user-defined route? Okay, I'll just wait for 10 more seconds on this particular question. I'd appreciate if everybody can participate in this. Okay. So the right answer is a user-defined route, right? So you create a user-defined route so that every traffic coming from a particular network is routed through a virtual machine, which is actually used for network traffic. So think of this virtual machine as a firewall, for example, right? So if you want all the traffic to go through a particular firewall, to go through a particular virtual appliance or a particular virtual machine, then you go ahead and create a user-defined route. Second question. So consider you have set up a disaster recovery in Azure using site recovery. Which service should you use or configure to redirect traffic to Azure when your on-premise systems are down? So would you use front door, application gateway, Azure load balancer, or Azure traffic manager? Okay, let me close this particular polling as well. Okay, so the right answer is Azure Traffic Manager, right? So Azure Traffic Manager, like I said earlier, is a DNS based redirection. So if your on-prem DNS, if your on-prem systems are down, it just goes ahead and redirects all the traffic to your disaster recovery site, which is in Azure, right? Azure Front Door is an HTTPS redirection only, right? Or HTTPS based load balancer, right? Application gateway is a very localized or a regional based service. So it's not a global service like Front Door or Traffic Manager. And Azure Load Balancer is not really a suitable option here, because uh, Azure Load Balancer will just redirect traffic to as a round robin, right, from one location to another location. So the right answer is Azure Traffic Manager. So that pretty much completes today's session. Let me quickly look at some of the questions. So there was one question from Prakash. Is there any throughput impact when using Bastion? The answer is no. There's no throughput impact. Could you please discuss about Azure VPN? So a quick summary about Azure VPN, Phil. There are different types of VPNs you can create. There's a site-to-site VPN, there's a point-to-site VPN, and there's an express route. So site-to-site VPN is a network, an on-premise network gets connected to an Azure network. Point-to-site is, think of it as a laptop or desktop from your on-premise being connected to an Azure network. That is point-to-site. Express route is a dedicated connection, a dedicated pipe between your on-premise data center and Azure. So these are the three options with Azure VPN. And depending on which scenario suits you, you can either choose one or more of them. A question from Abhay, does Microsoft provide threat hunting under EDR? The answer is yes. Microsoft definitely provides threat hunting with Microsoft Defender for Endpoints. Okay. So if there are no further questions, thank you very much for taking out time and joining me in today's session. I hope the session was helpful and informative. I will be available on the Q&A and the chat for the next 10 minutes. So if you have any questions, feel free to go ahead and post them on it. If not, thank you all very much. Have a great week and a great weekend ahead. Thank you.